Okay, using combination permutations. This is 10.2. A combination is an arrangement in which order is not important. For example, lottery numbers. How many of your parents have ever played the lottery? A few of you? So, it doesn't matter the order that they pick the numbers in, as long as your number shows up, you're good, right? So order does not matter. Okay, except for like, I think the last one sometimes. I don't know, I never play it. Right. Okay, where permutation, and this is what we are talking about in 10.1, permutations order is very important. Okay, so the difference between combination and permutation is in a combination, order is not important, and a permutation is where order is important. There are different formulas for these two. Okay, first thing we're going to do is just practice figuring out is something a combination or a permutation. Does order matter, order not matter? So, a classroom seating chart. Okay, but if you think about this classroom, you walk in. Can you sit wherever you want? No, it's a permutation. Order is important. Where you sit matters. Okay? So, if there is a seating chart, that means there is placement. Order is important. Okay. You guys might not know this one, but you should maybe remember it from geometry. But it is combination. The order does not matter. Okay? They're all the same. Also, okay, the batting order of the Pittsburgh Pirates.
It stays the same, right? The order is important because
Do you think the order is important? Do you think the coach makes the lineup? Yes, exactly. It is a permutation. Order is very important. And anytime you're like putting something in a specific order, that means order matters. Because if you weren't putting in a specific order, then obviously it wouldn't matter. Okay, 10 books on a library shelf. What do you think? So if you go to the library and think about if there was no order and you're trying to find a book, do you think that'd be very fun going to the library if there was no order? No, order is super important. Well, there's our problem. Okay. Permutation, order matters. Okay, a hand of 5 cards from a deck of 52 cards. Good, it doesn't matter which order you get the cards in as long as you get the cards you need, right? Okay, combination. Okay, a 7-person committee from your class. So if I'm choosing 7 people to form a committee, does it matter who I chose first, second, third, fourth, and so on? Exactly. Normally with committees, because it's not like saying like president or vice president, order doesn't matter. And so committee, you're going to see committee come up a lot. Committee is combination. C, C.
I was just going to say that.
Okay. Number 7. So for you band people, first, second, and third chairs from 6 clarinets in a band. Does order matter?
Yes.
Yes, it's super important. Permutation. Now this one has been debatable in years past.
Permutation. You don't present your best first. You do it
That's very true. I'm going with permutation.
So I would agree that this one is negotiable. Right. So this will not be a test question, I promise. It could be combination or permutation. We're gonna call it. We're gonna say order matters. We're gonna say permutation. Okay.
It does matter. It matters. They put like the best.
Since it's being modeled, and if it's being modeled, you don't, like we've heard people say in here already, you don't put your best dress out first. Order matters. The person that has designed these clothes has an order that they want you to see them in, and so this is why it is permutation. Okay. All right. Combination. So remember how I told you with permutation? Permutation, you don't really have to memorize the formula, right? Because you knew you have so many spots, and then you start with how many numbers and go down. Combination is different. You have to have this memorized. So you're going to want to circle, highlight. You're going to want to know this. So remember that this does go NCR, okay? So when you see them written like this, N is the number in front, R is the number at the end. So if we're using our formula, on top is always your biggest number, the number that was in front, which is 5 factorial. On the bottom, you're going to subtract the two numbers. What is 5 minus 2?
3.
So we have 3 factorial. And then it says you just want R on the bottom, which is 2 factorial. So again, just hope you remember, the number in front goes on top. Okay? Second number goes on the bottom. And you subtract the two numbers, and that also goes on the bottom. Okay? Then you want to write it all out. I'm going to kind of show you guys a little bit of a shortcut in a second. But so we have 5, 4, 3, 2, 1. On the bottom, I normally will start with whatever the smaller number is, put that one in front. So 2 times 1 times, and then the larger number I usually do second, so 3, 2, 1. Because what I'll end up doing is doing like 3 dot dot dot, so I don't have to write out all the numbers, okay? But you'll see what I mean in a second. So here the 3's cancel, 2's cancel, 1's cancel, that one cancels, and then what happens with the 2? 2 goes into 4 how many times? Twice, and 5 times 2 is? 10. So this answer is 10. Ones don't matter. Excuse me?
Where did the 3 come from again?
We subtracted 5 minus 2 to get 3.
Okay.
And then you put the 2 on the bottom. Okay, so this next one. What number is going to go on the top on number 2? 10. 10 factorial divided by 10 minus 5 is 5 factorial, and then you have another. Okay, did we see how all of these canceled out, like because they matched? So on the top, what I'm going to do is I know they're going to start matching at 5. So I write it out as 10 times 9 times 8 times 7 times 6 times 5, and then I just do dot 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 to remember that 5 is going down 4, 3, 2, 1. Okay, so one of my 5 factorials is going to cancel out, right?
Yeah.
But I'm going to have one that's not going to cancel out. So I'm going to write out one of them, 5 times 4 times 3 times 2 times 1. And then the other one I'm going to go 5 times 5 dot 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 instead of writing out 5, 4, 3, 2, 1 again. So these cancel out, and I cancel out those 5s. Is everybody okay with that? Did somebody say no? Do we realize that this would go 5, 4, 3, 2, 1? And this would also go 5, 4, 3, 2, 1. So instead of writing all of that out, I just did dots to represent that it keeps going down, and then I cancel them out. If you wanted to write it all out, you totally can, but we're going to get to some numbers where it's like 20. And you would obviously, it'd be much easier instead of writing 20, 19, 18, 17 to not do it. Okay. Does the 1 matter?
No.
No. Then you can decide how you want to cancel these out. I'm like, okay, 3 times 2 makes 6. 4 goes into 8 2 times. 5 goes into 10 2 times. Everything on the bottom will end up canceling out. So you just need to be careful at the top. Okay? So then what's left over, I circle it all that's left over. I have 2, a 9, another 2, and a 7. And I multiply those together, and 252 is the correct answer. Okay, so 3. On the top is going to be what? 12 factorial divided by, we subtract them, 12 minus 7 is 5, and then we have 7. And I did not give you guys very much space, or at least I don't have very much space. You guys might. No. You guys don't either. I'm sorry. Okay. So do your best here. So we go, which number am I going to stop at with the 12? 7. So write this out. 12, 11, 10, 9, 8, 7, dot, dot, dot. Over, which number should I start with, 5 or 7? 5. So I'm going to go 5, 4, 3, 2, 1, and then I'm going to go 7 and my dot, dot, dot. Okay, so the 7s and the dot, dot, dots cancel. 1 doesn't matter. And then it's your decision on how you cancel things. So anybody want to tell me how to do it? Good. 4 times 3 is 12, so I'm canceling out 4 and 3 and 12. Good. 5 times 2 is 10. Cancel that out. As long as you're multiplying right, it doesn't matter how you cancel things out. You'll still end up with the same answer. The only numbers that are left now, it looks like, are 11, 9, and 8. And we multiply that together, and what do we get?
792.
792 is the correct answer. Okay, what do you notice about this one? It's a permutation, which means, do you remember what we do for permutations? How many blanks am I going to make? What's the first one going to start with? 10, 9, 8, 7. Multiply that together. 5,040 should be the correct answer. Okay, are we good? Okay, on 5, what do you think is going to happen on this one? Blessy said it exactly correct. You're going to do both of these separately, and then you're going to get the answer and multiply the two answers together. Okay? So it's almost like you have 2 problems in one. So, first one. What are we going to do? 12 factorials on the top, divided by 12 minus 4 is 8 factorial, and then 4 factorial. So we're going to do that problem. So what number am I going to stop at on the top? 8. Good. So I'm going to go 12, 11, 10, 9, 8, dot, 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 over. And I'll start with what on the bottom? 4. So 4 times 3 times 2 times 1 times 8, dot, dot, dot. We can cancel out our dot, dot, dots and the 8s. 1 doesn't matter. From there, what do we want to cancel? 4 times 3 makes 12. 2 goes into 10 5 times. So I've left 5, 11, and 9, and you multiply that, and what do we get? 495 is correct. Okay, so there's one answer, and now we're going to do this other one, and I think we're going to skip 6 because I'm not going to have enough room. Okay, don't cry about it, I'm sorry. Okay. I know, it'll be okay. Okay, so then this one, if you can still read it, it's 8C3. Do we agree? So what's going to go on top? 8 factorial divided by 5 factorial, 3 factorial. So with the 8, I'm going to stop at what number? 6. 8 times 7 times 6. Actually, I'm going to do 5 and then dot, dot, dot. And what will I start with on the bottom? 3 times 2 times 1 times 5 dot, dot, dot. Now what happens? Okay, those will cancel. 1 doesn't matter. 3 and times 2 makes 6. So we have 8 times 7 left over, which is 56. And so then your final answer is? Good. 495 times 56, which equals? Perfect. 27,720. Okay, questions? All right, now we're moving to the fun stuff, which is the word problems. Hopefully you'll remember the difference between combination and permutations, because each time you get to one of these problems, you need to think to yourself, is this a combination or is this a permutation? Example 1. How many committees of 5 students can be selected from a class of 25. Is this a combination or permutation? Okay, how many are there to choose from? There's 25C5. This is what the problem looks like. So when we find out this answer, what's going to go on the top? 25 factorial divided by what? 20 factorial and 5 factorial. Do you guys already have that formula memorized? Yeah. See, practice, make sure you remember it. It's good. All right, so I'm going to stop at what number on the top?
20.
Okay, so 20 times, or 25, 24, 23, 22, 21, and 20, dot, 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 over, what am I going to start with on the bottom? 5. Okay, so go ahead and write that out. So I have 5, 4, 3, 2, 1, and then 20, dot, dot, dot. So we cancel out our 20s, our dot, dot, dots. 1 doesn't matter. And then what happens? Good. 4 times 3 times 2 is 24. Again, if you didn't see that, you could cancel out the 2 with 22, and then the 3 with 21, and then the 4 with 24. It'll all work out the same. Okay? 5 goes into 25 how many times? 5. So we have a 5, a 23, 22, 21. Multiply all that together, and you get... Good. 53,130 different combinations of students that could be chosen. That's pretty crazy, huh? Okay. Example 2. How many ways can first, second, and third place be awarded if 20 people are running a race? Is this a combination or permutation? Because order definitely matters. So there are 20 people running this race, and there are 3 places. How do I solve this one?
3 blanks.
Thank you. 3 blanks. And we're going to start with 20, 19, 18. We multiply those together and we get 6,840 is correct. Okay. Example 3. Did you guys get that one? Yeah? No, we didn't get this one? Okay. Example 3, we're ready for 3? Yes? Okay. A box contains 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen? Okay, first of all, do you think it matters which black one you choose first? No. Okay, so on these ones, you have to pair them up kind of together. So you have 12 black, and how many black are we choosing? 3. Okay? And then you have 8 green, and you're going to choose 2 of the green. And we decided order didn't matter, right? Yeah. So we have to do these separately. So we have 2 different combinations that are happening here. So we have 12 combination of 3, and then the other one would be 8 combination of 2. So again, remember we have to do these problems separately and then multiply them together to get the answer. So on the first one, we're going to do 12 factorial divided by 12 minus 3 is 9 factorial, 3 factorial. So on the top, I'm going to end up going up until 9. 12, 11, 10, 9, dot, 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 over 3 times 2 times 1 times 9, dot, dot, dot. We reduce. 1 doesn't matter. I'm going to have to go, let's do it this way this time. 2 goes into 10 5 times, and then 3 goes into 12 4 times. So I have 4 times 11 times 5, which makes 220. Okay, so now we have to go do our other problem. So on the top will be 8 factorial divided by 8 minus 2 is 6 factorial, and then 2 factorial. So we go 8 times 7 times 6 dot 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 over 2 times 1 times 6 dot dot dot. These cancel, 1 doesn't matter. 2 goes into 8. 4 times 7 is 28. So now for your final answer, we go 220 times 28, which makes, you guys are waiting to say it, 6,160 is correct. Okay, example 4. Some of these I'm going to do a little quicker so that we can finish here. From a group of 12 boys and 10 girls, how many committees of 5 boys and 5 girls can be formed? So it is C is correct. But again, you have to do the boys because so many boys are chosen, and then you have to do the girls because so many girls are chosen. So for my boys, my combination is what? 12 combination 5 for the boys times the girls is 10 combination 5. If you went through all the work on this, $12 combination 5 is what? Anybody get it already? It's 792. And 10 combination 5 would end up being 252. And we multiply those together. And your answer is 199,584. Is that okay that we don't work all that out for our notes? You guys are good with combinations? Okay, so last one. I just want you guys to try to set it up. You don't have to do all the work. I'll end up telling you the answers. But on example 5, I'm going to give you about 30 seconds to try to set it up on your own. And maybe even set up like how you would end up solving it, you know, with the factorial things, but you don't actually have to find that answer, okay? Okay, so what's the first combination? So we're doing the girls. There's 22 and 2, so you said it's 22. Good. Times, and then we have our boys, and it's 16C3. So on the 22 combination 2, you would set it up as what on the top? 22 factorial divided by 20 factorial, 2 factorial. And again, I get the 20 because I'm going 22 minus 2 is 20, and then I keep the 2 on the bottom. If you did all that math, you'd end up getting 231. Okay, times the 16C3, what goes on the top? 16 factorial over, good, 13 factorial, 3 factorial. And if you did all that math, you'd end up getting 560. And if you multiply those together, your final answer is, you guys are amazing, 129,360 is correct.